Hey folks, how's it going? It's Mr. Murray coming to you with a Do Now video for Course 1 Honors for Thursday, May 21st, 2020. And wow, this week is going by so quickly. We're getting ready to end this 9th week of the school closure, and we're getting ready for what I know will be an amazing hangout tomorrow. So here's the question for today. A town is planning to build a new school. The school committee knows that there are currently 1,100 students at the school. They expect that the student body will grow at a rate of 2% per year. If the school will take 2 years to build and will likely need to be either replaced or renovated 25 years after it initially opens, how many students should the building be able to fit? Before we get started in solving this problem, I will tell you that the ideas covered by this problem were discussed earlier in the week. So if you have not done the lessons earlier in the week around modeling, I would suggest you take a look at the lessons before you attempt this problem. Okay, or maybe if you might not know how to solve it, that might be a place where you go to get a refresher. Okay, also to help you interpret the directions here, I would recommend that you kind of highlight some important information to clarify. What we know is that the school is going to open 2 years from now, and that 25 years after that, we're going to need to plan to have either, adding on or, building a new school entirely. So we need it to be able to fit enough students when it opens to be able to fit students until we get to the renovation point, right? So for example, let's say we started building the school in 1998. It would be completed in 2000. It would take 2 years. And then I would want it to be able to fit enough students so that in 2025, I could be ready to renovate and go from there. Okay. So basically, I want to know how many students will be here in 2025, if this was the context, so that I can tell the school committee and we can plan accordingly. All right. So folks, please take a moment thinking about what I said, pause the video, attempt this problem. Then when you're ready, unpause and you can see what I got. All right, here we go. So, all right. So the first thing I'm going to do is I'm going to try to pick out some important information, right? Because our goal is we want to make a function f of x equals a times b to the x that models this particular situation. Okay. And so what we know is that if we think about x as years from now, right? So it represents years. So if now is 2020, x is 0, right? So then 2025 would be x is equal to 5. 2027 would be x is equal to 7, for example. Okay, so a represents the value when x is equal to 0, right? Because 0 will make b to the 0 equal 1. So, well, look, 0 years from now, how many people are in the school? We know that. So that means that a is equal to 1100. Okay, so because it's got to be a number that when you plug in 0, you get 1100, because currently represents x is equal to 0. Okay. But what about b? B is the rate of increase. So first of all, here's two important words: grow. So when we see words like grow, increase, appreciate, add, expand, things like that, those last ones, I don't know if you'd see those a lot, but I'm just trying to give you words that you might see. We're gonna have a sense that we're having exponential growth. When we see words like decay, contract, decrease, lose value, decline, we should be thinking decreasing. So this is exponential increase. And so what we know is that each year the student body will have 100% of what it had last year plus an additional 2%. So for example, if my student population was 1,000 students, this is 1,100, but let's say it was 1,000. I would have at the beginning of next year the 1,000 students I had before, right? Plus an additional 2%, right? 10 new students who came on, right? So like you might know every new year, sometimes new students come to Milton High School, right? So that is in a sense where our growth is coming from, right? Some students come, some students go, okay? And so then we're at 1,100 now. So next year we'll have that 1,100 plus some additional new students, and so on and so on. Right now we will have people who will graduate, right? But we know that other people will come in, and they will kind of fill those numbers out, so to speak. Okay. So what that means is that our B value is 1.02. Okay. And so if you haven't seen it yet, please take a look at my video on exponential growth and decay and modeling, because it's always either going to follow 1 plus or 1 minus, because either we're going to be starting with 100% and adding due to growth, or we'll be starting at 100% and subtracting due to decay. Okay. So we'll write f of x equals 1,100 times 1.02 to the x. All right, now I'll be honest. From here, there is nothing you can realistically do without some form of calculator, whether that be online, which if you're seeing this video, I'm assuming you have access to potentially, or you have a handheld one, maybe a graphing calculator. You need at least a scientific calculator, and your iPhone calculator will work. But if you're going to do that, you first have to do the exponent before the multiplication. Okay, you have to do it in the order of operations. I recommend you use this Desmos calculator at desmos.com/scientific. Okay, or just search Desmos Scientific Calculator. Now here, I know that by the time I'm going to need to be renovated, it's going to be 27 years later. The 2 years, because if you think about it, right, I'm going to the school committee, hey, give me some money, all right? Or we're going to ask for some money. I don't know if the school committee will give me the money, but someone will. Look, we need money to build a school. But the reality is, in our projections, if we are going to ask for money, we need to think about, well, how long is this school going to last, right? We want to make sure that in 25 years, there's enough people so that we have plenty of time down the line to consider when we need to be looking for space. So if we can say, look, this building can hold the number of people that we expect to have in 25 years, right, then that will be a pretty good thing, hopefully, depending on if that's realistic. So we'll have to take a look. So we have 1,100 times 1.02 to the power of 27. And here's where you'd use your scientific calculator. So this is my Desmos. 1,100, again, desmos.com/scientific. 1.02 okay, so there we go. We have 1,100 times 1.02 to the 27, that's going to be giving us 1,878 students. So realistically, if you had a building that could fit 1,900 students, then you could say, look, we have a building that, based on our models and our projections, if we continue to grow at a rate of approximately 2% per year, we have a building that's large enough to not only have enough students to space to hold the students when we first open, but to have enough space to hold students for at least the next 25 years. Okay, and at that point, since we know that, we can start having discussions about what to do around that, as we get closer to that time. So hopefully you're able to get this question correct. If so, great job. I do encourage anyone with a graphing calculator to continue to develop your skills with using that. If you have questions about that, I'm happy to answer. Look, if you don't have a graphing calculator, that's also completely fine. We'll develop those skills in school over the next, few years, and I wouldn't worry about that. But if you do not have your own scientific or preferred graphing calculator, please make sure you have access to one that's online. Either at Desmos, use Google Calculator, use Wolfram Alpha. You have to have access to something. All right, so best of luck. Don't forget to love math. And remember, you can do it.